Okay, so today's notes are over the quadratic formula. So this whole chapter, we're working with quadratic equations. And you know how to solve quadratic equations by taking the square root, by factoring, by completing the square. And now you're going to know how to solve quadratic equations by using the quadratic formula. So there's just another tool in your toolbox. So the equation that we're going to use is the opposite of b plus or minus the square root, and you should have seen this in Algebra 1, this is not brand new, of b squared. Now, normally the books will say -4, but I like to say plus a -4 because people make far less sign mistakes when you say plus a negative. AC all over, oops, that's not how I meant to write it, 2a. So there's our formula. There's the quadratic equation. If you remember, when we have something in standard form, the a is in front of the x squared, the b is in front of the x, and the c is in front of, or c is the constant. Okay, so let's plug this into our equation. And when we do these problems, we are not going to use decimals at any point. We're just going to leave them as radicals, and I'll show you how that works as we get there. Okay, so on this one, the opposite of b would be 4 plus or minus. And when we do these problems, I like to really not start evaluating anything until we get further into it. First, start by plugging the number in. The only exception I make is squaring the b. So b squared would be positive 16. Every time we square it, it's going to be positive because we're plugging it in, so it's in parentheses, plus -4 times a, which is 3, times c, which is -9, all over 2 times a, which is 3. So step 1 is just plugging it in. If you try and do more than that in the first step, you're going to end up with a mess. Okay, the next step is to multiply everything out underneath. Okay, so -4 times 3 is -12, and -12 times -9 is positive 108. So when I multiply these three things, I get positive 108. I'm going to add 16 to that, and I get the square root of 124 all over 2 times 3, which is 6. Okay, before we can do anything else, we got to simplify the square root of 24. That's a funny looking 2. Okay, so let's see what goes into 124. Well, it's even, right? So I can do 124 divided by 2, which is 62. 62 is even, so I get 2 and 31. 31 is prime, though. It stops. So it simplifies to 2 square root 31. So I'm going to rewrite this as 4 plus or minus 2 square root 31 all over 6. Now, before we split it up, because this is actually two things, we're going to reduce it. So if there's a number that goes into the 4, the 2, and the 6, so all three of this, it can't be 2. It's got to be all 3 because it's addition. If there's a number that goes into all 3, not the number under the radical, but all the other 3, then we can reduce it. So I'm going to divide them all by 2. And then I can write my final answers. So one answer is going to be 2 plus 1 square root 3, or 31 is just 31, square root of 31 over 3. And the other is going to be 2 minus the square root of 31 over 3. And there's our answers. Okay, let's try this again on number 2. Now, when we do these, though, the quadratic formula only works if our equation is set equal to 0. If it's not, then we have to set it equal to 0 before we begin. So number 2 is set equal to 0. So my A is 1, my B is -9, and my C is -27. Okay, so if we plug it in, the opposite of B would be 9 plus or minus the square root of b squared is 81 because it's always positive, because when you plug something in, it's in parentheses, plus -4 times a, which is 1, times c, which is -27, all over 2 times a, which is 1. So let's deal with under the radical. When I simplify this, I'm going to get 9 plus or minus -4 times 1 is -4 times -27 is going to give us positive 108. And then we add 81 to that. And so we get 189 all over 2. Okay, before we go any further, we got to simplify the square root of 189. Well, it's not even, but it is divisible by 3. I just punched that into my calculator. Okay, 63 is divisible by 3 also. We get 3 and 21, and then we get 3 and 7. So I have one pair of 3s. So outside of my radical, I have the 1, 3. Anything that's not paired up goes underneath and gets multiplied. So I get 3 square root 21. So when I rewrite this, I'm going to have 9 plus or minus 3 square root 21 all over 2. And now I'm going to check, is there a number that goes into 9, 3, and 2? It has to go into all 3 of these. And the answer is no, there's not a number that goes into all 3 of these. So now I'm going to write my answer as 2 things. So one is going to be 9 plus 3 square root 21 over 2. And the other is going to be 9 minus 3 square root 21 over 2. And there's my answer. Okay, let's try this again on number 3. Number 3, it's set equal to 0, so we can begin. So this is my A, this is my B, and this is my C. All right. So when I plug this in, the opposite of B would be -6 plus or minus the square root. B squared is 36 plus -4 times A, which is 2, times C, which is 3, all over 2 times A, which is 2. Okay, so this gives me -6 plus or minus the square root of, and then up here, -4 times 2 is -8. -8 times 3 is -24. So 36 and -24, they're opposite signs, so you subtract. Take the sign of the bigger number, you get 12. All over 2 times 2 is 4. Okay, now we need to simplify this radical. 12 is 2 and 6 and 2 and 3. So the pair represents a number outside. Anything not paired up goes back underneath. So this is -6 plus or minus 2 square root 3 all over 4. Now, not including the radical, if there's a number that can go into all 3 of these, you can reduce. And the number that goes into all 3 of these is 2. So this is going to be 3, 1, and 2. So my final answer is going to be -3 plus 1 square root 3 is really just the square root of 3 over 2. And my other answer is going to be -3 minus square root 3 over 2. And those are my 2 answers. Okay, on number 4, you cannot do the quadratic formula unless it says equals 0. And this one most definitely does not say equals 0. So to start, I need to subtract 2x from both sides. When we write this, it has to be x squared, x, and then our constant. If it's not in that order, it won't work. So I have 3x squared minus 2x plus 7 equals 0. So now this is my A, this is my B, and this is my C. So to put it in my formula, the opposite of B would be 2, plus or minus the square root of B squared, which is 4, plus -4 times A, which is 3, times C, which is 7, all over 2 times A, which is 3. So when I simplify this, I get 2 plus or minus the square root of, multiply this. -4 times 3 is -12. -12 times 7 is -84. Plus +4 gives me -80 all over 6. Okay, so when I simplify the square root of 80, I'm going to get 8 and 10, 2 and 5, 8 is 2 and 4, and 2 and 2. So I'm looking for pairs. Each pair represents one number outside of the radical. Anything not paired up goes back underneath. If I have more than one number inside or outside, I multiply them together. And so I get 4 square root 5. But I wasn't just taking the square root of 80, I was taking the square root of -80. And anytime we take the square root of a negative number, we have to add I. So when I write my answer, I'm going to have 2 plus or minus the square root of 4 square root 5 I over 6. Okay, now if I can find a number that goes into 2, 4, and 6, has to go in all 3. If it doesn't go in all 3, it doesn't work. They're all divisible by 2. So I can reduce this. So I get 1, let me screw this up, plus 2 square root 5 I over 3. and 1 minus 2 square root 5i over 3. And so we get our two answers. All right, that's the quadratic formula. But the quadratic formula, part of it can also be used to find the number and the type of solutions. And we call that the discriminant, okay? And the discriminant, we can say, is used to find the number of solutions and the type. Okay, so we're not actually solving it. Now, if we have a quadratic equation, then that means we have an x squared in there. That means we should have two solutions, but it's not always that cut and dry. So let me give you this. Well, first of all, the discriminant is just the part under the square root. So it's b squared minus 4ac. So what we have here is we have three graphs, and we have the equation that goes with that graph. So what I want to do is find the discriminant and then figure out what that discriminant is telling us. So we remember that this is A, this is B, and this is C. So the discriminant is B squared. So B is 1. So 1 squared is 1 plus, and remember we made this minus plus negative. Okay, plus negative 4 times A, which is 1, times C, which is negative 2. So when I add this together, negative 4 and 1 is negative 4 times negative 2 would be positive 8. So my discriminant is 9. Okay. So what does this tell us? Well, in this situation, the discriminant, and the discriminant we know is b squared minus 4ac, which in this case turned out to be 9, but it could be anything. But comparing it to 0, it is greater than 0. And anytime it turns out like this, and the discriminant is greater than 0, which means it's a positive number, that means that we're going to have two solutions, and they're both going to be real. And the two solutions happen where the graph crosses the x-axis. So here is number 1 solution, and here is number 2. So let's go back and take a look at this. Let's go back and look at number 3. Number 3, the discriminant is the part under the radical. That turned out to be a positive 12, and we had 1, 2 real solutions. They're goofy looking, but they're real numbers. Okay, I'm going to skip and do this out of order for a second. I want us to look at the third one for a second. In the third one, this is my A, this is my B, and this is my C. And we're going to define this discriminant, b squared plus negative 4ac. So b squared would be 9 plus negative 4 times A, which is 1, times C, which is 3. So we have 9 plus negative 4 times 1 is negative 4, times 3 is negative 12. So that gives us negative 3. So my discriminant is negative 3. So if I was describing this discriminant, we could say that this discriminant was less than 0, which means that it's a negative number. Okay. And when that happens, we are still going to have two solutions. But over here on this first one, I said there's two solutions, and it was where it crosses the x-axis. This graph over here on the right clearly never crosses the x-axis. So where are the solutions? Well, they're not here at the x-axis. That means the type of solutions, they're not real numbers, they're imaginary numbers. Okay, so let's look at example 4. Under the radical, we ended up with, we ended up with a negative 80. And when there's a negative 80, we put an I in our answer. So we ended up with 2 imaginary solutions. So anytime the discriminant is negative, we have 2 imaginary solutions. Here's what the graph looks like. It never crosses the x-axis. When the discriminant is positive, here's what the graph would look like. It's going to cross the x-axis twice. But what if this situation happens? What if our graph just touches the graph once? Okay, or the x-axis once? What is that? Well, let's figure out what this discriminant is and see what happens. Well, this is my A, this is my B, this is my C. So my discriminant is b squared, which would be positive 16, plus negative 4 times a, which is 1, times c, which is 4. So we get 16 plus negative 16, which is 0. So my discriminant was 0. This time, the discriminant, which is b squared minus 4ac, was equal to 0. So I got three options. It can be positive, it can be equal, or it can be negative. And when it's equal to 0, we're only going to have one solution. But you're saying, well, you just told me if it's quadratic, we have to have two. That just means that the solution repeats. You know how sometimes we factor something and we get the same number in both parentheses, like we're doing when we're completing the square, we get +3 and +3. So that solution repeats. It occurs twice, but it's the same number. And it's going to be one real solution. Okay. And the one real solution is right here where it crosses the x-axis, but it's a repeated solution. Okay, so now that you've got the rules, so it can be positive, 0, or negative. If it's positive, it's 2 reals. If it's equal 0, it's 1 real. And if it's negative, it's 2 imaginary. So now let's try another equation and see if we can figure it out. So remember, we're finding the discriminant, and the discriminant is just kidding. The discriminant is not what I meant to put, is b squared plus negative 4 times a times c. Okay, let's plug this in. Here's my A, here's my B, here's my C. So B squared would be 64 plus negative 4 times A, which is 16, times C, which is 1. So I get 64 plus negative 4 times 16 is negative 64 times 1 is negative 64. Positive 64 and negative 64 is 0. So my discriminant is 0. When my discriminant is 0, that's the middle thing. So that tells me I have one solution. It's a repeated solution, so it occurs twice, and it is real. Okay, let's see what happens on the next example. This is my A, this is my B, and this is my C. So I'm going to find the discriminant. So the discriminant is B squared. So negative 5 squared is positive 25 plus negative 4 times A, which is 2, times C, which is 6. So I get 25 plus negative 4 times 2 is negative 8. Negative 8 times 6 is negative 48. So when I add those together, they're really opposite signs. So I'm subtracting, take the sign of the bigger number, I get negative 23. So my discriminant is negative 23. Now, negative 23 is not a solution or an answer. It's just giving us information about the equation. And that information, that's option 3. The discriminant is negative. That means there's 2 solutions and both of them are imaginary. Okay. Try this on your own and we'll review more next class.